Hi, welcome to Concept Based. I'm John Hepworth. This is your Year 11 Extension Parametric Equation question, and I'm going to do it, I wouldn't say incorrectly, but not the way you've probably been taught in Year 11. The reason being is that when we have these parametric equations with cos and sine functions in them, we're taught that a really easy way to relate them together is by squaring them and adding them together, which is such a cool little trick because what it does is that it uses that identity sine squared plus cos squared equals 1. But what if you forget that that's the trick? And what if you just stay with the concept that the way of solving parametrics is make t the subject in one, sub it into the other, and then see what is resultant? Well, this question gets a little difficult through the middle of that. And you've got to remember not just your algebra, but some trig rules to get through the middle, which I'm going to show you right now. So, given the parametric equations x equals 3 cos t, y equals sine t, describe the features of the resultant function. So what I'm going to do is I'm going to make t the function, t the subject in x equals 3 cos t. And to do that, I'm going to divide by 3 and then take the inverse cos. So t equals the inverse cos of x on 3. Now I'm going to sub that t into the y function. So now y equals 3 sine of inverse cos of x on 3. And now we are at this trig point where we're doing a trig function of an inverse cos function, a sine of an inverse cos. And you just need to use the one rule that I try and help my students get through a bunch of questions with, which is draw a picture. If you draw a right angle triangle here, and you say, well, if this is theta, the inverse cos is talking about adjacent over hypotenuse, but then we're going, so this is theta here, but then we're going to find the sine of that. So that's the opposite side. So we better use a bit of Pythagoras. 3 squared is 9 minus x squared square root. And we can do the sine of that. So now we can say y equals 3. The sine of this is opposite root 9 minus x squared over hypotenuse 3. The 3's cancel. We square both sides and we get y squared equals 9 minus x squared. We add x squared to both sides and we get x squared plus y squared equals 9, which I'm going to write as 3 squared because here's the circle we expected to get out. So it works going down this different algebraic method, which is the concept you've been taught. The question does say describe the features, so I'm saying it's a circle, center, 0, 0, radius 3, and we're done.